Picture this. A threat enters your system, and honestly, before your fingers even hit the keyboard to open a terminal, it's already compromised your core infrastructure. So what happens when cyber threats move literally faster than human engineers can even type? Well, welcome to today's Explainer. We're going to be digging into a really fascinating autonomous AI solution that's designed to do just that, outpace modern malware. Today, we're looking at a deeply compelling architectural framework called Guardian Cloud. It's essentially an autonomous AI co-pilot, and it's completely reshaping cloud operations and cybersecurity as we know it. My goal for this explainer is to demystify this cutting-edge multi-agent architecture and show you exactly how it takes complex server management from a frantic, reactive scramble and turns it into a highly secure, automated science. Okay, let's dive right into this. First, we'll look at the cloud operations crisis, then meet the AI task force, peek inside the model zoo, check out G-Coder and AI meetings, explore the safety net, and finally, wrap up with scaling security. All right, starting off with Section 1, the cloud operations crisis, or as we like to call it, the breaking point. Think about modern site reliability engineering teams for a second. We're talking thousands of alerts, endless notifications, and let's be real, most of them are non-critical. It's the classic alert fatigue, and the scary part is, it means genuinely dangerous anomalies just slip right through the cracks. And as businesses grow, they inevitably need more sysadmins, which creates an expertise scaling problem that is just not economically sustainable. You really have to contrast that manual struggle with attack speed asymmetry. Human mean time to respond, MTTR, usually takes tens of minutes, sometimes even hours. But malware penetration, that happens in minutes. Automated exploits don't sleep, they don't take coffee breaks, and they sure don't need to read manuals to figure out what to do. Traditional deterministic scripts like Ansible or Terraform, they just cannot adapt on the fly to these zero-day anomalies. Which brings us to Section 2, meet the AI task force and their decentralized multi-agent architecture. So the solution here isn't to just build one massive, slow neural network that tries to juggle everything all at once. Instead, Guardian Cloud uses a highly specialized, decentralized team of AI agents. It's like a digital task force. It all starts with a low-level host agent sitting right on the target server. It acts kind of like a mechanic, gathering telemetry and filtering system calls, all while using literally less than 1% of your CPU. It securely fires this data up to the AI officers in the cloud. Up there, you've got the master agent acting as the manager and orchestrator. Then there's the sysadmin agent handling configuration, health, and performance. And finally, the ITDR agent, which basically acts as your dedicated security guard for threat detection. So the really crucial point here is how they communicate, and that's through the inter-agent consensus protocol. Instead of relying on a sequential, slow chain-of-thought reasoning process, these agents actually use dynamic consensus. Think of it like this. If the security guard, the ITDR agent, spots a suspicious file, it immediately requests a process map from the sysadmin agent. Only when both explicitly agree that an attack is happening, based on correlated network traffic and file activity, does the orchestrator actually step in to isolate the threat. This collaborative double-checking process is an absolute game-changer for minimizing false positives. Okay, moving on to Section 3, inside the model zoo, basically the brains of the operation. This whole ecosystem relies on a highly customized fleet of neural networks. They're fine-tuned using LoRa, which means they can adapt incredibly flexibly to specific client domains without forgetting their core system skills. And to make this massive intelligence run efficiently without just burning through colossal, expensive GPU infrastructure, they use advanced quantization techniques, things like AWQ and GPTQ. This basically compresses the models and saves massive amounts of memory. Now, what's really interesting about this slide is how it grounds the theoretical AI into hard engineering reality. Look at these production validation scores. We've got the Quen P30B model acting as the audit officer, pulling in 97% validation score for finding critical issues. The Gemma 426B handling ITDR with 94%. And then you have the self-hosted GLM 5.2 acting as the central main brain and validator for those high-risk reviews. They are just incredibly specialized and highly, highly accurate. But as you know, accuracy isn't everything. In cybersecurity, speed is everything. Just look at this number, 726 to 952 milliseconds. I mean, that is sub-second anomaly detection speed achieved by their ultra-fast, lightweight Cuban 3.4B models deployed right at that first line of defense. In literally less than a second, an anomaly is detected and flagged. That absolutely shatters traditional human response times. It's wild. Let's jump into Section 4, G-Coder and AI meetings, focusing on autonomous refactoring. So while the sysadmin and ITDR modules are busy working at the infrastructure and operating system level, the G-coder subsystem goes so much deeper. Powered by the GLM 5.2 model, it actually dives straight into the application's source code to autonomously fix logic bugs and modernize legacy code on the fly. And the way it does this? It's straight out of a sci-fi movie, happening seamlessly right inside VS Code. Picture an interactive AI meeting. You, the human developer, give a prompt to design a new module. The orchestrator then assigns submodels from the GLM 5.2 family to act as an architect, a coder, and a tester. They literally debate the architecture, discuss algorithmic complexity, and write the code all while you just sit back and watch the logs in real time. Of course, you can intervene at any moment, direct the logic, or just step back and let them solve the whole shebang autonomously. Which leads perfectly into Section 5, the human-in-the-loop doctrine, essentially the safety net. Look, if the idea of an AI autonomously rewriting your source code sets off massive alarm bells about rogue AI taking down your servers, well, you definitely aren't alone. But Guardian Cloud addresses this head-on with a strict architectural doctrine that prioritizes safety and control above absolutely everything else. Let's walk through this autonomous operational lifecycle. First up, deep semantic context analysis of the incident. Second, the synthesis of fixes, like generating a patch. Third, sandboxing the fix in an isolated environment to make sure it compiles and doesn't break anything else. But let's slow down for step 4 here, owner verification. The AI is fully autonomous in finding the problem, writing the code, and preparing the solution. But deploying those critical changes to a production environment, that absolutely requires a human in a loop to verify and approve it. And let me tell you, that approval process is locked down extremely tight to prevent any sort of account compromise. They use a 5-factor authentication model. You need a master password, session email verification, Telegram integration, a hardware TOTP token, and biometric web authn. Stacking all of these together creates a virtually impenetrable multi-factor gateway. Ultimately, only the legitimate system owner can greenlight these critical infrastructure changes. Moving to our final section, Section 6, Scaling Autonomous Cloud Security, where we'll look at the economics and the future of all this. Beyond the obvious technological superiority we've been talking about, this setup offers a super flexible pay-as-you-go commercial model. You're only paying for actively connected servers and the actual volume of analyzed telemetry. This allows businesses to scale their infrastructure and security infinitely without just linearly increasing their engineering headcount, which, as you can imagine, is a massive economic advantage. Furthermore, for managed service providers, hosting platforms, and data centers, there's even a white label integration available. They can basically bake this autonomous admin directly into their control panels right out of the box. It allows them to seamlessly scale their business and offer an advanced AI sysadmin to their burn clients without having to furiously expand their own support teams. Which really brings us to the final and I think most fascinating point of today's explainer. If a multi-agent AI system can collaboratively debate architecture in VS Code and autonomously patch zero-day exploits in literally under a second, what exactly will the role of the human engineer look like tomorrow? The source material strongly suggests that humans won't be the ones writing routine code or putting out fires at 3 in the morning anymore. Instead, they'll be the architects and commanders, verifying the brilliance of their digital agents. It is a completely new, vastly more efficient paradigm for the future of DevOps, and it's coming fast. Thanks for exploring this with us today.